So it can be a double decomposition reaction, double displacement. Okay, why it's known as double displacement? That is also known as the previous case which we did, there was single displacement or metathesis reaction. Okay, all meaning are similar, they all are same. Okay, so it can be anything. So let's get into the topic. So what do you mean by double decomposition reaction? When both the reactant in the compound form, okay, the reactant is in the compound form which is on the left side, are decomposed, means breaking down, to give two new compounds. We are going to get new compound on the product side, this is on the right hand side, by exchange of the radicals. To they exchange their radicals so as to form a new compound, okay, from the old one. Okay, so that is known as double decomposition reaction, double displacement, or metathesis reaction. Okay, so if you will see now this one, okay, there is a compound, there is a reactant side, there is a compound. Okay, this again one more compound, both are reactant. Yes sir, both are reactant, and they are giving you the products. Okay, again they are in the compound form. So now we will read. See, if you will see nicely, the reactants means X is a reactant, Y is a reactant. Okay, reactant. Okay, so what they are trying to say, after in the product side they are together. No sir, they are not together. Now X came with B and Y is making a compound with A. So they are exchanging themselves with another reactant, okay, in a compound form on the reactant side only. So the reactant side, so one reactant getting exchanged with another reactant and forming a new compounds. So what is exchanging? The radicals. So X is a radical getting compound with B, Y is a radical making a compound with A. Okay, so what is a radical? You know what are radicals? Okay, so a group of atoms will make a radical, you know these all things. Okay, because of exchange of radical, they are forming a new compounds on the product side. Okay, now you may ask that why X is only making the compound with B, why not with A? Here you see, for example, we will assume as X as positive 1, Y as negative 1, A will be positive 1, B will be negative 1. Now tell me, the positive will go with positive or negative? Sir, with the negative. So X with B, XB, Y with A, YA. Sir, how you came to know this is a positive, negative? It's just a symbols. Okay, it's a symbol. It's only representation form. Now I will show you the compounds. Okay, where you will come to know. Obviously, metals will be positive and non-metals will be negative. From there, we will come to know. Okay, this is a represented form. This is the way they will represent this one. So you understood that both reactant. So these are the reactants on the left hand side, which is in the compound form. So it's a compound. It's a compound. Decompose means they will break down. They will break down. For example, it is going to break down. Okay, XY is there, na? XY. If it will break down, what will become? So X plus Y. So X is positive here, Y is negative. It will be always in aqueous solution. Aqueous is water. So why sir water? Because it will help them to decompose. What they say, both reactant are decomposed. So it will decompose like this, and AB is there in aqueous solution. It will also break A plus B minus. Okay, like this it will break down. After breaking down, okay, they give two new compounds. The positive is going to pull the negative one, okay, towards itself, and the negative is going to pull towards positive. So like this they will make a compound. So until unless they are separated, it's not possible to make the new compound. Okay, because they are already having some bond with them. Okay, they need to be separated. They need to be the bond which is present between them, which is holding them together. Okay, that bond need to be separated. So for that we are using aqueous solution or water. Okay, what they do, they separate the ions to individual form. After separating like this, they makes a bond with one more ion and forms a new compound by exchange of the radical. They exchange the radical with another one and forms a new product. So this is the way they, and very important, aqueous solution is very important. It should be in aqueous solution only, then only they can decompose. The word decompose is there. Okay, so the small example representing what I told you. Okay, we'll see now how it works. Okay, see here it's a compound on the left hand side, and use the right hand side is a product is there. So now if I will see, so what is zinc? Sir, zinc is a metal. So metal, sir, it will have positive. Okay, now what is the SO4? So SO4 is a negative one. Okay, negative one is the radical, sir. Okay, negative one. So what about again NH4 is there? Okay, NH4. Okay, NH4 ammonia is a metal, sir. Metal, okay, positive one. So what about this one as CO3? So CO3 is a negative one radical. Okay, now what is happening? You see, So they are always in aqueous solution. If it is written or it's not written, it's aqueous solution, because they need to decompose. This need to decompose. When they decomposes, only they form exchange the radical. Without decomposing, now it's in the bond form. There is a compound form. There is some bond is there, some energy is there which is holding them together. So that bond should be broken down. So the bond which exists between Z and SO4 should be broken down so that they will be separated, and like this they will also separated, and they will form a new compound by exchange of the radicals. Understood? See, the Zn plus is making a bond with Cu minus, Cu3 minus. Okay, this minus is making a bond with this one. So they need to be broken down. Okay, by it will help them by aqueous solution only. Understood? Okay, how it is represented? Okay, they should decompose the word, every word I am explaining, that it should decompose. After decomposing in the aqueous solution, they exchange the radical with the next reactant and form a new compound in the product side. In double decomposition reaction, okay, these are the types. The first type is precipitation reaction. So first type is precipitation reaction. Okay, now what do you mean by precipitation reaction? Reaction between two compounds. Again, there is a two compounds. Okay, on the reactant side, again they have written aqueous solution. Okay, aqueous solution state to give two new compounds. Again the same thing they are saying, one of which is insoluble. So here what they are giving stress on insoluble. So one of that product side will be insoluble. So that is known as precipitation reaction. Okay, we'll see. So says again, this is the first one. The left hand side two things are there: soluble salt. Okay, salt plus soluble salts. Okay, reactant side. Now in the product side we got a soluble salt and an insoluble salt. Down arrow. So down arrow is there. So down arrow represent that is a salt which is insoluble. If sir the arrow is at the top side, just like this one, if the arrow is this one, it's a gas. If arrow is like this, it's a gas. Okay, showing it's a gas. If the arrow is like this, showing it's a precipitate. Okay, so this is a precipitate. Okay, so if any reaction we are getting any insoluble salt, okay, that is known as precipitation reaction. So we know this one. Again the same thing is there. It's type of decomposition. In double decomposition we have different types of this is a, if in double decomposition reaction, if I am getting, okay, this down arrow, or if I am getting any precipitate, then I will say it's a precipitate reaction. In which reaction it is coming? In double decomposition reaction. Okay, how it came to know that it's a double decomposition reaction? Because if you will see, there is exchange of radical. The calcium is a positive one. We know calcium is positive, making a bond with negative. So sodium is positive, making a bond with chlorine. See, they are forming. So there is an exchange of radical. Okay, there is exchange of radical between them, between the reactant, and you are getting the product. Okay, and on that, in the product side is a down arrow is there. So down arrow, what it does show? Insoluble salt is a salt is there which is insoluble. So from here we came down, it's a double decomposition reaction. In that it's a precipitation reaction because of this down arrow. If you'll see now, okay, there's the equations. Again there's equations. So if you'll see on the right hand side, there's a arrow is the downwards, arrow downward, arrow down. So from here we came to know, okay, these are what? These are precipitate salt. These are precipitate salt. Precipitate salt. Okay, means precipitation reaction is this one. Okay, from we came to know. In which reaction does precipitation reaction come? It's a double decomposition. So it's a double decomposition reaction. In that it's a precipitation reaction. We have got this one by seeing this down arrow, which is known as precipitate. Okay, precipitate, insoluble salt which is not able to dissolve in the solution. Okay, so you understand exchange of the radical is taking place. This all things I have already clearly explained you. In the double displacement, okay, it's a part of the reaction, means type precipitation reaction. You understood what is precipitation reaction? Okay, next one. So there is a next type of reaction, that is known as neutralization reaction. It is also a part of double decomposition reaction. So how many reactions are? Only two are there. Precipitation we understood, as well as neutralization is also a part of the double decomposition reaction. So these are the different types of double decomposition reaction. Okay, so we saw that. Now you see the definition what they're trying to say. Okay, both reactant, okay, in the bracket is a compound. Okay, you know the reactant or compound obvious composed to give, again decompose. So they should be decomposed. Yes sir, to give two new compounds. They will get a new compound on the product side. Okay, by exchange of their radical. So they are going to get the new compounds. Okay, on the reactant side. If you feel the video was informative and helpful to you, and it is helping you a lot, please hit like and share among your friends, and subscribe also. Okay, we are going to get the product side two new compound by exchange of their radicals only. We know this one. Yes sir, we know this one. Okay, So if you'll see like this, okay, so in this neutralization reaction, okay, so what is happening? Reaction between two compounds. Again, there is a compound, we know that one. The compound is now not a salt. Okay, in previous case precipitation reaction, there were two salts on the reactant side. Okay, and in the product side also we are getting the two salt. It may be soluble or insoluble, doesn't matter, but every case, okay, of what do you say, precipitation reaction, we have the salt. But in this case we have the base and the acid has a reactant, and we are going to get salt and water. So the reaction between two compounds, again there's a compound on the left hand side, okay, which is reactant side, there's a base and an acid. So we have the base, OH will be there, or O will be there, base you know how to identify, and acid also you know how to identify with H. Okay, to give two new compounds, we are going to get new compound, that is salt and water. See, salt is there and water is there. By exchange, again there is the same thing, exchange of the radical. So here also there is exchange of the radical. So from here we came to know it's a part of the double decomposition reaction only. Okay, so in the previous case, if you are getting two salts in which one is insoluble, that's a precipitation reaction of double decomposition. Here if you are getting salt and water, okay, by exchange of the radical, it's a neutralization reaction of double decomposition reaction. Okay, so this all comes under double decomposition only. So that one we can identify by the downwards arrow, there's a precipitation reaction, and here we are going to get salt and water. If you are getting salt and water on the reactant side, product side, so it's a neutralization reaction. Clear? You see. Now if you'll see nicely, again here also this will break down into Na plus and OH minus, and this will break down into H plus Cl minus. So after that they do make a bond with a positive with a negative. The positive will come with a negative one, and this will come with like this. So form from compound. Understand what I'm trying to say? So there is exchange of radical in this case also. Here we are getting water and salt. So it's a neutralization reaction, very important reaction from the exam point of view. So there are some more reactions. Again, it's a base with an acid, salt and water. Base with an acid, salt and water. So everywhere if you'll see, identify the downward arrow means you'll understood. So water you are getting with some salt means you understood it's a neutralization reaction which is a part of double decomposition reaction. You understood this one? There are many examples are there, okay, regarding neutralization. So up to you it's clear? Yes, it's very clear for us. So there are some more reactions. As we know that in the previous case, okay, in precipitation reaction we are going to get insoluble salt by using a soluble salt in the product side. So can we get a soluble salt? In this way we are going to get a soluble neutralization reaction. Okay, we uses the insoluble oxides, insoluble oxide, insoluble oxide. This is a insoluble hydroxide, insoluble hydroxides. Okay, oxides and hydroxides. So by reacting with an acid, okay, we are going to get a soluble salt. These all are soluble salts. So what are these? So these all are soluble salts. So how can we get a soluble salt for? Okay, you can say by neutralization reaction, which is a part of double decomposition reaction. If they ask you how to get insoluble salt, then you know precipitation reaction. So to getting a soluble salt, we can use this method. Okay, from the oxides, from hydroxide, where is the base is an oxide, where the base is an hydroxide. So these all are soluble salts. Okay, it's not an insoluble. So if it is an insoluble salt, then it will be something else reaction. Okay. So from here we came to know that we can prepare a soluble salt, okay, by using neutralization reaction, which is a part of double decomposition reaction. Insoluble salt, sir, by precipitation reaction. Okay, clear? You understand what are these type of? So in double decomposition reaction we get neutralization reaction as well as precipitation reaction. So you understood exchange of the radicals, everything you understood clearly. Okay. Now there are some more applications of neutralization in everyday life. You will see the first one. Adding lime or alkaline to the soil reduces the acidity. Means acidity means the amount of acid present in the soil has increased. So it can destroy the crop. So for that it should be reduced. So we'll use what? We'll add in lime. So because of that, acid plus base, lime is a base. So it's salt and water. So okay, like that. Adding lime to lakes to reduce the effect of acid rain. Again the same thing. Okay, taking injection tablets. So these are the applications. They are very important. Okay, you should write it's all things. So we are using everywhere we are using neutralization. Okay, so we get salt and water so as to reduce the acidity. So for example, if I am going to any party, we are having some food. Okay, after we feel uncomfortable. So what we do? We take a okay, that's a base. So increase the acid got increased in our stomach. So we are adding the base. So what you get? Salt and water. So it's getting there. We are getting the reduce. The acidity is getting reduced. In the same case, if a honeybee comes and stings us, okay, then what happens? We apply something of that. So we have successfully completed the next part of double decomposition reaction, precipitation reaction. Everything we have completed with a nice examples. Okay, so we have completed all the parts in this reaction. Next class, if any more topics are there, I will come with that one, or we will do a worksheet over all the 4 types of reaction.